The last part of this section deals with properties of limits. Now what we're going to notice a lot in this class is that we're going to look at properties of all the different things that we learn. And I always relate it back to this. When you started learning about math, you had to learn how to add, subtract, multiply, and divide things, right? So we needed to figure out how to add, subtract, multiply, and divide natural numbers, and then integers, and then fractions, and then polynomials, etc. So what we're looking at now are properties of limits. And again, within that, we're going to look at, okay, how do you add, subtract, multiply, and divide? What are the properties that govern what we're looking at? So let's suppose a few things. Let's say that the limit as x approaches a of f of x exists and that it's equal to L, and the limit as x approaches x of g of x exists and that it's equal to m. Then all the following are true. The limit as x approaches a of k is equal to k for any constant k. So the limit of a constant is equal to the constant. Kind of like we saw in example number 5. -3 is a constant. There is no variable. The limit of the constant is always going to equal the constant. The next property says the limit as x approaches a of x is equal to a. Well, that makes sense. So that's just direct substitution for us. Next, the limit as x approaches a of f of x plus g of x is equal to the limit as x approaches a of f of x plus the limit as x approaches a of g of x, or L plus m. This allows us to look at taking the limit a term at a time. The same thing for the next one. The only difference is that now we're looking at subtraction. So the limit as x approaches a of f of x minus g of x is really just equal to the limit as x approaches a of f of x minus the limit of x approaches a of g of x. You'll have this next one happen with everything that we look at in terms of derivatives and integrals and limits. So the limit as x approaches a of k times f of x is equal to k times the limit as x approaches a of f of x for any constant k. So what I like to say is constant multiples, because if you notice here, k is multiplying f of x. Constant multiples will always multiply along. One under that says that you can take limits and you can separate them using multiplication. Next one says you can look at limits and you can look at them as the limit of the numerator divided by the limit of the denominator. And finally, the last one is just saying, all right, if you want to take the limit as x approaches a of the nth root of f of x, you can just find the limit as x approaches a of f of x and then take the nth root of that. That's all that we have there. So let's use these properties to work the following problems. Let's say that I give you that the limit as x approaches 3 of f of x is equal to 2, and the limit as x approaches 3 of g of x is equal to -2. Well, what is the limit as x approaches 3 of 5 times g of x? Well, 5 is a constant multiple, and if we look at our properties above, constant multiples multiply along. So this is equivalent to 5 times the limit as x approaches 3 of g of x. Well, I know that the limit as x approaches 3 of g of x, this is equal to -2. Therefore, this is 5 times -2, which is equal to -10. So the limit as x approaches 3 of 5 times g of x is equal to -10. All right, the next one, the limit as x approaches 3 of -3 times g of x minus 5 times f of x. First, I can split up subtraction. We know that we could write this as the limit as x approaches 3 of -3 times g of x minus the limit as x approaches 3 of 5 times f of x. And then both -3 and 5 are those constant multiples, so we know that we can rewrite this as -3 times the limit as x approaches 3 of g of x minus 5 times the limit as x approaches 3 of f of x. Well, I know that the limit as x approaches 3 of g of x, that this thing here is equal to -2 minus, and I know that the limit as x approaches 3 of f of x is equal to positive 2. So now I just need to figure out what is negative 3 times negative 2 minus 5 times 2. Therefore, you're looking at 6 minus 10, or negative 4. So the limit as x approaches 3 of negative 3 times g of x minus 5 times f of x is equal to negative 4. Again, I know that I can split this up into the limit as x approaches 3 of g of x minus 2 over the limit as x approaches 3 of 1 plus 2 times f of x, because I'm allowed to split it up over numerator and denominator. And I also know that I am allowed to split this up over addition and subtraction, and I can take out constant multiples. So then this becomes the limit as x approaches 3 of g of x minus the limit as x approaches 3 of 2 over the limit as x approaches 3 of 1 plus twice the limit as x approaches 3 of f of x. Well, again, I'm given that the limit as x approaches 3 of g of x is equal to negative 2 minus, well, the limit as x approaches 3 of 2, well, this is the limit of a constant. 2 is just a number, and the limit of a constant is the constant, over the limit as x approaches 3 of 1. Well, again, the limit of a constant is the constant, and 1's a constant because it's just a number, plus 2 times, well, the limit as x approaches 3 of f of x was given as 2. So we have negative 2 minus 2 over 1 plus 2 times 2, or in this case, we're looking at negative 4 over 5. So the limit as x approaches 3 of g of x minus 2 over 1 plus 2 times f of x is negative 4/5. Number 26. Well, I know that if I have an nth root, I can rewrite this as the 5th root of whatever the limit as x approaches 3 of 12 times f of x minus 4 times g of x is. And then again, I know that I can split that up as, again, here's a constant multiple, and here's a constant multiple. So 12 times the limit as x approaches 3 of f of x minus 4 times the limit as x approaches 3 of g of x. So this is going to equal the 5th root of 12 times, well, again, the limit as x approaches 3 of f of x is equal to 2 minus 4, and again, the limit as x approaches 3 of g of x is equal to negative 2. So this is the 5th root of 24 plus 8, which is 32, so this is equal to 2. So the limit as x approaches 3 of the 5th root of 12 times 5x minus 4 times gx is equal to 2. That's it for section 2.1.